Okay, so states of matter. States of matter. طبعا we know that we have three states of matter. صح? Gas, okay, liquid, and solid. Three states of matter. طبعا sometimes people would say, well, Mr. We have four states of matter. We have plasma as well. I know plasma might be the fourth state of matter, but for the sake of our course, we're only going to be talking about these three states of matter and the different properties of each state, which you mostly know of. So, for example, changing from gas to liquid, you'll say, well, this is condensation. Changing from liquid to solid, this is solidification. Going from solid to liquid, this is melting. And from liquid to gas, this is evaporation or boiling. Okay, and then we can talk about the properties of each state. We can say, for example, the forces between the molecules in the gas are very weak. In the liquid are a bit stronger. The solid are the strongest forces. The distances between the molecules in gas are very far away. In liquid are closer together. We can say that they are loosely packed. You can say that they are loosely packed. In the solid, you can say that they are very close or that they are closely packed. For example, if you want to talk about the volume, the solid has a fixed volume, the liquid a fixed volume. Fixed volume, gas, the volume it takes up the volume of the container. But when we talk about the shape, the solid also has a fixed shape. The liquid doesn't have a fixed shape. It takes the shape of the container, and the gas also takes the shape of the container. خلاص. The speed of the molecules, the motion of the molecules. If you want to talk about the motion of the molecules, the solids, they vibrate in fixed places. The liquids, they slide over each other. But the gases, they move. When you talk about the motion of the molecules in the gas, especially in the gas, you have to say that they move fast and random. You must say that they move fast and random in all directions. Usually it's worth 2 marks. But you must say they move fast and random in all directions. Okay, well, that's easy. Solids, liquids, and gases. Like, if I want to draw a heating curve, okay, if we want to draw a heating curve, let's draw a heating curve for a solid. Okay, for example, if I take out some ice from the freezer. Okay, if you take out some ice from the freezer and you check the temperature of this ice, initially the temperature of the ice taken out of the freezer would be less than zero. Okay, it wouldn't be zero. It has to be less than zero. -10, -20, -30, and definitely we are talking in degrees Celsius. Okay, we are talking in degrees Celsius, which is the main unit for the temperature in our course. There's another unit I'll be discussing later, inshallah, called the Kelvin. Okay, but for most of the equations, we will be talking about the degrees Celsius. So if I take out a couple of ice cubes from the freezer, their temperature, for example, would be -20 degrees. -20 degrees. Okay, this is the temperature. Okay, in degrees Celsius. So -20 degrees, and with time, okay, with time, or with heat added, or whatever. On the x-axis, it could either be time or it could be temperature. I'm sorry, heat. It could be time or heat. The y-axis is the temperature. When I take out the ice cubes from the freezer, the temperature is -20. Do they instantly change to liquid? No, they don't instantly change to liquid. It might take a couple of minutes or a couple of seconds, depending on the temperature of the room. It would take some time to reach 0 degrees Celsius, which is the melting point of ice. So it takes some time. Okay. In this time, the temperature of the ice starts to rise. The temperature of the ice starts to rise from -20 to 0, which is the melting point. I know you know these things, but I'm gonna just quickly discuss them. From -20 to 0, what's happening? The temperature of the ice is rising. At 0 degrees Celsius, you start the melting process or the melting phase, at which the temperature remains constant. The temperature remains constant while you're changing from solid to liquid. So you have a mixture of solid and liquid. If I look at the cup, مثلا, I took the solid ice cubes and I put them in a cup. After a couple of minutes, I can find a mixture of ice and liquid. This mixture of ice and liquid, the temperature of this mixture is 0 degrees Celsius. Okay, it will remain zero. It will remain zero until what? Until all of the ice has melted. Until all of the ice has melted and turned into liquid. When all of the ice melts and turns into liquid, the temperature starts rising again. The temperature starts rising again. If I take this cup or if I take this container and put it above a Bunsen burner or whatever heater and I start to heat the water, it will keep on heating up. The temperature of the water will start to rise until it reaches a very important point. Very important temperature, which is the the boiling point, which is 100 degrees Celsius. Again, 100 degrees Celsius. The boiling point at which the water starts to we can see some bubbles. Okay, you can see bubbles forming inside. Okay, you can see the bubbles forming inside the liquid. These bubbles that form inside the liquid mean that the liquid has reached the boiling point. When the liquid reaches the boiling point, what happens بقى? It keeps on boiling for some time. Keeps on boiling for some time until all of the liquid has changed to gas. خلاص, when the liquid بقى changes to gas, the temperature can increase above 100 degrees Celsius. When the temperature increases above 100 degrees Celsius, خلاص, يبقى بس as long as there is water and as long as this water is boiling, the temperature will remain at 100 degrees Celsius. As long as, for example, there is ice and the ice is melting, then the temperature will remain constant. So in these latent phases, we call them latent phases. This is the latent phase, and this is a latent phase. What's a latent phase, يا شباب? It's when you're changing from one phase to another. You're changing from solid to liquid. So I'm changing from solid to liquid in the melting. صح? This is the melting phase. Temperature is constant. Temperature is a constant. At what? At 0 degrees Celsius. Start. What about the other phase? This is the boiling phase. The temperature is also constant. Temperature is constant at what? Temperature at 100 degrees Celsius. Boiling and melting. خلاص, that's it. That's it. It's quite easy to understand this part of the session. But the second part is when we need to talk about the difference between evaporation and boiling. Sometimes we say, well, I have water which changes to gas. This water, or this process, you could either say that it's called evaporation or boiling. What's the difference between evaporation and boiling? First of all, we need to define evaporation. You need to define evaporation. What happens, okay, evaporation. What happens during the evaporation? This is a question worth usually 3 or 4 marks. Okay, it's a question in paper 4, usually worth 3 or 4 marks. What is evaporation, شباب? والله, evaporation is the process at which water turns into gas. صح? لا, no. We need to talk in a more specific or in more details. How can I talk in more details, شباب? The most, you have to say that the most energetic molecules, the most energetic molecules escape from the surface, from the surface, leaving behind the least energetic molecules, leaving behind the least energetic molecules, decreasing the average temperature, decreasing the average, you can say to decrease the average temperature, or you can say that the average kinetic energy decreases, because the kinetic energy is related to the temperature. As you increase the kinetic energy of the molecules, the temperature increases, and as you decrease the kinetic energy, the temperature decreases. So when you decrease the average temperature, you're actually decreasing the kinetic energy of the molecules. خلاص يبقى most energetic molecules escape from the surface. You have to say that the most energetic molecules are escaping, not just any molecules, that the most energetic molecules with the most temperature, with the most heat, escape from where? From the surface, leaving behind the least energetic molecules, causing the temperature will decrease. This effect is called what? It's called the cooling effect, causing a cooling effect, causing a cooling effect. خلاص يبقى for example I have a cup of coffee. After a while this cup of coffee gets a bit colder. The cooling effect, why does it get colder? You need to state this whole sentence. Okay, most energetic molecules escape from the surface, leaving behind the least energetic molecules, causing a cooling effect. طيب decreasing the average temperature. What's the difference between evaporation and boiling? Let's write down the differences between them. How boiling and evaporation. Yeah, what's the difference between boiling and evaporation? 2 points. أولا, boiling, yes, boiling has a specific temperature. Specific temperature. For example, water boils at 100 degrees Celsius, but evaporation happens at literally any temperature. Evaporation happens يا شباب at any temperature. Meaning that if you have cold water, will it or could it evaporate? Yes, it could evaporate. Cold water could evaporate. It would evaporate. If you leave the water long enough, it would evaporate. If I have a cup of water and I leave it for a couple of days or a couple of months, okay, in a room, خلاص, what will happen after I come back? I will find that it has evaporated. Why? Because of that the most energetic molecules escape from the surface, leaving behind the least energetic molecules. So at any temperature, the water will evaporate, or any liquid could evaporate. Boiling happens throughout the whole surface. Oh, sorry, it's throughout the whole liquid, throughout the whole liquid, through the whole liquid, but the evaporation only on the surface. So only on the surface. Plus, only at the surface. Yes, and you're saying that boiling has bubbles. That is correct. Evaporation doesn't. Okay. بس يعني boiling happens throughout the whole liquid, but the evaporation happens only on the surface. خلاص يبقى this is evaporation. طيب, another point which we talk about is the Brownian motion. أهو البراونيان motion. What is the Brownian motion? Why does the Brownian motion occur? It's because we have the air molecules. First of all, we need to say, how do the air molecules move? Wallahi, the air molecules move fast and random. We need to say that the air molecules move fast and random in all directions. So they move fast and random in all directions, colliding with what? You need to say that the air molecules collide with the smoke particles, not the other way around. If you say that the smoke particles collide with the air molecules, this is wrong. The air molecules collide with the smoke particles. يلا, colliding with the smoke particles. Particles causing a random zigzag motion. يلا, a random zigzag motion. Random zigzag motion. This motion has to be random and it has to be a zigzag motion. Meaning that if you draw, for example, if he tells you, well, I need you to draw a motion for this smoke particle, how will you observe this smoke particle? How will it move? If you draw it with any curves, for example, this way, لا, this is wrong. Okay, طب if I draw a zigzag motion, بس a non-random zigzag motion with a pattern, if you draw it with a pattern, for example, if you draw it this way, this would also be wrong. This is a zigzag motion, yes, zigzag motion, but this is wrong. Why? Because there is a pattern. How can I draw a random zigzag motion? For example, a line and then it's moving in random directions. Okay, the directions are never the same. Okay, you can draw upwards, downwards, with diagonal, whatever بقى. بس you need to draw at least 3 or 4 lines in different directions, and you need to draw the arrows on these lines. That's it. Okay, this is the Brownian motion. And then you have some questions related to the thermal expansion, which is quite easy. Thermal expansion, if I say the thermal expansion, let me write it down. What is the thermal expansion? Well, thermal expansion is that literally anything, any matter. Whenever you heat up some matter, it expands. Whenever you heat up matter, what happens? It expands. طب how does it expand? It's not because the molecules themselves get bigger. It's because the molecules move further apart. Because when you increase the kinetic energy of these molecules, they move further apart. Okay, as temperature increases, okay, as the temperature increases, the volume increases. Why? Because the molecules move further apart. طيب خلاص. This is the thermal expansion, and then we talked about the some of the advantages and the disadvantages of the thermal expansion. One of the most popular advantages of the thermal expansion was the thermometer. صح. One of the most popular advantages was the thermometer. Advantages was the thermometer. Thermometer. But the disadvantages, for example, was the buckling of the train tracks. Okay, buckling of train tracks. And that's why in train tracks we need to leave these small spaces between the sections to allow for the thermal expansion, usually during the summer. During the summer. حلو. طيب جميل. Last part, which is a bit new, okay? This is relatively new, which has been added to the syllabus just a couple of years ago, is the Kelvin scale. It's actually very, very easy. What is this Kelvin scale? I told you, احنا when we talk about temperatures, we usually measure the temperature of water or temperature of whatever in degrees Celsius. But in fact, there's another there's another scale which is called the Kelvin scale. Okay, Kelvin scale. What's the Kelvin scale? It's the absolute scale. Sometimes we say that it's called the absolute scale. What do you mean by an absolute scale? In temperatures in water, for example, when you freeze the water, it becomes ice at 0 degrees Celsius. You can decrease the temperature even more. -10, -20, -30, 40, 50, 60, negative temperatures. Type. To which extent can I decrease this temperature? To which extent can I decrease this temperature? There's a limit. There has to be a limit. This Kelvin scale has to do with the kinetic energy of the molecules. What do I mean? As you decrease the temperature, what happens to the kinetic energy of the molecules? It decreases. As you decrease the temperature, the kinetic energy of the molecules decrease. طيب, I will keep on decreasing the temperature and the kinetic energy will keep on decreasing until what? Until virtually, يعني, the molecule or the atom or it will stop moving at all. It will completely stop moving. Okay, you know that the solid vibrates in fixed space, صح? طيب, this vibration will keep on decreasing until what? Until it kind of stops vibrating at all. When does it stop vibrating? At 0 degrees Kelvin, or at the absolute zero. Okay, at the absolute zero. What is the absolute zero? Or how can I measure this absolute zero? The Kelvin scale, the Kelvin scale, how can I measure temperatures in Kelvin scale? K equals C plus 273. What is K? It's the temperature in Kelvin. Okay, the temperature in degrees Kelvin. The temperature in degrees Kelvin. طيب, what about the C? It is the temperature in degrees Celsius, صح? In degrees Celsius. So, for example, if I tell you, والله, I need to find the temperature of boiling water. I need to find the temperature of boiling water in degrees Kelvin. I need to find the temperature of boiling water in degrees Kelvin. طيب خلاص, يبقى temperature of boiling water in degrees Kelvin would be K equals C plus 273. So for example, boiling water would be K equals 100, which is the degrees Celsius, plus 273, which is basically 373 degrees Kelvin. That's it. That's it. But can you find the temperature of freezing water? Can I? Yes, I can find. Oh, freezing. Freezing أو solidification أو whatever. K equals 0 plus 273, which is 273 degrees Celsius. صح. طيب, what is the temperature in degrees Celsius, of the least temperature that, oh, the least possible temperature? What is the least possible temperature? بصوا, what is the least possible temperature? The least possible temperature is what is the 0 degrees Kelvin, which is, in other words, the absolute zero. Oh, this is the absolute zero. Yani absolute zero, it is the least temperature that could be reached by any particle. Okay, it is the least kinetic energy of this particle. طيب, least possible temperature 0 degrees Celsius. Can I find it in degrees 0 degrees Kelvin? I'm sorry. Can I find it in degrees Celsius? Yes, you can find it in degrees Celsius. Oh, so 0 equals C plus 273. So if you and take the 273 to the other side, it would be in degrees Celsius, it would be negative 273 degrees Celsius. That's the least possible temperature that any molecule or any atom in the universe could ever reach. Okay, negative 273 degrees Celsius. That is the absolute zero. Or in other words, we can say 0 degrees Kelvin. Okay, the minimum temperature, the least amount of temperature, the least amount of kinetic energy. Okay, zero energy, zero kinetic energy. طيب, حلو حلو خلاص. يبقى this is the Kelvin scale, which is يعني quite easy. Okay, it is quite easy. يعني Mr. What are the questions? يعني what are some of the questions that we could have in the test? For example, he could give you a temperature in Kelvin. Okay, he will tell you, والله, the temperature in Kelvin. Let's say, for example, if I say that temperature today, the temperature is 400 degrees, or the temperature of some hot uh, iron or whatever is 400 degrees Kelvin. Okay, the temperature of this iron is a 400 degrees Kelvin. Can you convert this temperature into degrees Celsius? Yes, you can. هنقول ايه والله 400 equals C plus 273. To find the temperature in degrees Celsius, just minus 273, which would be 127. 127 degrees Celsius. So the temperature, if you say 400, yes, 400 minus 273, yes, you are right. Okay, so it would be 127 degrees Celsius. This is the temperature. Okay, they are both the same temperature, but using different scales, using a different scales. Well, relatively easy scales. Alhamdulillah that we didn't take the Fahrenheit scale. Fahrenheit scale is honestly, it's quite stupid. I hate the Fahrenheit scale. بس يعني the Kelvin scale is very easy. It's either you add 273 or you minus 273. If you want to find the degrees, the temperature in Celsius, minus 273. If you want to find the temperature in Kelvin, you just add 273, and that's it. That's all you need to know. But what about the absolute zero? Absolute zero is the least possible temperature. Okay, it is the least possible temperature. That's all you do. What is the least possible temperature? It is the least amount of kinetic energy that could be found in a molecule. That's it. That's all you need to do. All you need to say while talking about the absolute zero. طيب, let's solve a couple of questions كده. Okay, let's solve a couple of questions بسرعة كده. Let's open up paper 4. Okay, يلا كده open up paper 4 on states of matter. يلا part 1 طبعا. Okay, paper 4 اهو. يلا, last time احنا we were doing pressure, so today احنا we want to open up states of matter. Okay, and as usual, let's solve from Mm, from the back, page. What was the last page in states of matter? Da, da, da. Ah, page 318. Okay, page 318. Now, this is one of the newer questions. One of the newer questions. يلا بينا. Okay. Okay, state the name of the lowest possible temperature. I just said it, صح? The name of the lowest possible temperature is the absolute zero, صح? The absolute zero. Thank you. Okay, يلا بينا. Let's write it down. The absolute zero. طيب, nitrogen boils at 77 degrees Kelvin. 77K is degrees Kelvin. Calculate the boiling point of nitrogen in Celsius. Can I do it in? Yes. The actual equation is what? K equals C plus 273. Can I find C? Yes, C would be equal to K minus 273, which is 77 minus 273. That is 100 negative 196 degrees Celsius. صح? Please correct me if I'm wrong. طيب, easy. سهلة يا مستر. طيب, ايه. Okay, good. Moving on to next question. And temperature of a fixed mass of um, احنا we didn't talk about this yet. This is PVT, صح؟ pressure. احنا we need to talk about the pressure. So PVT احنا we will discuss it in just a couple of minutes ان شاء الله. It's a matter of minutes. احنا we will talk about PVT. هنا برضو sample again this is the same. طيب, let's move on to the previous question. Okay, let's move on to this question. Hot air blows into the drum. احنا we have a dryer. Okay, the moist air enters the condenser. Cool air leaves the condenser, passes through the heating element, and enters the drum again. Yes, thank you. State the process by which the hot air removes the water from بالظبط. This is the evaporation. صح. Evaporation. يلا. The cold air is cooled as it passes through the condenser. Describe and explain one other way in which the air leaving the condenser is different from the air entering the condenser. One other way. Huh. Do you know? Does anyone know the answer to this question? Okay, let's more dense, less energy. Okay. ماشي. يلا يا شباب. ها. اوكي, حلو قوي. It is حلو. Particles have less energy. ماشي. The leaving molecules have more kinetic energy. Okay. So yes, you can say that it is drier. Okay. هو بصوا, the cooled air the cool the air is cooled. يعني the air is cooled. بص يا شباب, يعني the air is cooled, يعني the temperature is different. فاحنا we need to talk about something else other than temperature. We need to talk about something else other than temperature. خلاص, يبقى the air is drier, meaning that the water has um, condensed, for example, or turned back to liquid. ما it's dry خلاص. Okay. Yeah. Okay. The water or the air is drier. Why? Because it has turned back to liquid. Has turned to liquid. يلا, to liquid. Oh, this is easy. The drum of the tumble dryer rotates, lifting the wet clothes, and then they fall. Name the force that causes the clothes to fall down. What's the force that causes them to fall down? طبعا this is the gravitation force or the gravity or the weight. خلي بالكوا, I usually into you're saying gravity, and I don't like to say gravity. Why? Because gravity by itself it's not a force. You can say, to be more specific, say gravitational force. Okay, not gravitation potential. لا لا لا, not gravitation potential energy. Gravitational force. This is the force that pulls down. Okay, or you can say weight. Weight is what pulls down an object. Okay, but not just gravity. Not just a gravity. طيب, يبقى أنا I prefer to say sometimes weight, which is easier than saying gravitational force. ماشي. When the drum rotates too fast, when it rotates too fast, the clothes remain in contact with the wall of the drum. State the direction of the resultant force on the clothes during the circular motion. During the circular, طبعا this is easy. Circular motion يعني centripetal force. In which direction is this centripetal force? والله towards the center of the rotation. صح. Towards the center of the rotation. يلا. Towards the center of rotation. صح. Hmm. Easy. صح. Okay. يلا. This is part C. We have part A and B. يلا. Let's solve part A, B, and C. Three identical dishes A, B, and C contain equal an equal volume of water. Dish A is outside in sunlight, experiences no wind during the day. Dish B is outside in sunlight and experiences a strong wind during the day. Dish C is in a dark room. صح. Water evaporates from each dish after 12 hours. The student measures the volume of water in each dish. Dish C contains the largest volume, which is quite obvious. And dish B contains the smallest volume. Again, obvious. Explain in terms of particles why the three dishes have different volumes of water. This is a nice question. Evaporation. I probably forgot to say what are the things that affect the evaporation, but so we have three things that affect the evaporation. First of all, uh, is the surface area of the container. Okay, surface area of the container. Second of all, you need to say the heat or the temperature of the water, and third, you need to say the wind. Okay, if you have some wind أو أي حاجة, this would also affect the evaporation. In terms of particles, why the three dishes have different volumes of water? Interesting. Okay, so yes, sunlight increases the temperature, increasing the evaporation as molecules on the surface escape faster as they have more kinetic energy. This is correct. Okay, ماشي حلو. طبعا يا شباب احنا we need to talk about the temperature. Okay, you need to talk about the sunlight that it provides kinetic energy. Okay, it increases the kinetic energy so they escape at a faster rate from the surface. Again, the wind, dish B, the wind removes more molecules from the surface. صح. And increases the rate of يعني احنا we need to talk about these two things. He did not talk about the surface area. خلاص يبقى. Okay, so first of all we'll talk about the sunlight. Okay, the sunlight provides energy, heat energy, which increases which increases the kinetic energy of the molecules, increasing the rate of evaporation. Why? Because you have, since there are more, since there are more highly energetic molecules. Okay, energetic molecules. Okay, and the second point you need to talk about the wind. Okay, the wind removes more molecules. Okay, from the surface. From the surface. Why? يعني how does this help? Increasing the rate of evaporation. بس كده. اوكي. طيب. easy. ماشي سهل. Define specific latent heat of evaporization or vaporization. This has been removed from the syllabus. Latent whatever has been removed from your syllabus. So whenever you find a question related to latent heat, okay, latent whatever, it has been removed. Okay, so just ignore the question. Okay, describe what
Mister,
occurs in each. Yes.
Mister, just the last question.
Ah,
ثانية بس.
okay.
خلاص thank you.
Okay, you're welcome. Okay, yeah. Describe what happens at A, B, C, and D. Okay, yeah. In each of these sections, they're different. A, what happens to the temperature? Wallahi, the temperature of the water increases. You need to say that the temperature increases. بس كده بس كده temperature بس what sorry I'm sorry it's not water it's solid temperature of the solid increases بس كده yes that's it أو temperature of solid increases أو heating solid أو whatever طب B what is B this is the melting process or melting phase صح. Yes, melting. And you need to say that as you are in the melting phase, what happens? Okay, as you're in the melting phase, the ice melts or the solid changes to liquid at constant temperature. Oh, solid changes to liquid at constant oh temperature. Type C, this is liquid, so the temperature of liquid increases. The temperature of liquid hmm, increases. And D, this is the boiling phase. Yeah, boiling phase in which the liquid yeah, changes to what? To gas, okay, at constant temperature. At constant temperature. صح؟ طبعا you can say that it's at 100 degrees Celsius and the melting is at 0 degrees Celsius. Okay. Easy. صح. I think it's easy يعني. يلا. Let's solve one more question. One very easy question actually. Solids have a fixed shape. Liquids adapt to the shape of the container. Gases fill their container. Explain in terms of forces and arrangement of molecules why solids, liquids, and gases have these properties. Forces and arrangements. So basically, we need to say the forces between the molecules in the solids are very strong. صح? And what about the arrangement? والله they have a fixed arrangement. صح? Or lattice arrangement. So you have very strong forces, very strong forces between the molecules, and lattice or fixed arrangement. يلا. Lattice or fixed arrangements. طيب, what about liquids? والله they have weaker forces, and the forces between them are strong, but not as strong as solids, so they're a bit weaker. صح? Um, and طبعا the arrangement non-fixed, so it's not fixed. Weaker forces than solids, and you're saying but stronger than gas. Yes, you can say that, but stronger than gas. And arrangement, okay, is not fixed. صح. You can say that they are sliding over each other. صح. Oh, actually, he didn't ask about the motion. If he asks about the motion, you can say that they're sliding over each other. Can I say it takes the shape of the container? Um, you can say it's taking the shape of the container, بس يعني need to be more specific when talking about the arrangement. Okay, I didn't ask you about the shape. I'm talking about the arrangement. I know they're quite similar, but the arrangement when I'm looking at molecules, when I'm looking at each molecule on its own. If I looked at the molecules in the solid, I'd find lattice arrangement. يعني it has a pattern, but in the liquids لا, there's no pattern. Okay. Yes, you said irregular arrangement. Yes, you can say irregular arrangement. Yes, irregular arrangement. Okay. In gases, the forces are very weak. Forces are very weak. Irregular arrangement, and they are far apart. Okay. They are far apart. Okay. طيب. Okay. Yeah, that was easy. I guess states of matter is one of the easier يعني one of the easier lessons we have in our syllabus, especially because most of you have taken chemistry, so it's quite easy for us. خلاص. Again, evaporation, we talk about evaporation. Why evaporation? Because most energetic molecules escape from the surface, leaving behind the least energetic molecules. The factors that affect the evaporation, خلاص احنا we said the surface area, the temperature, and the wind. خلاص. كلهم they are the same basically. Again, oh, this question, latent heat. Okay, latent has been removed. Latent heat has been removed. Okay, فخلاص هنا boiling, what happens to the temperature of the water in the beaker when it's boiling, the temperature remains constant. خلاص كلهم they're the same. Difference between evaporation and boiling. خلاص we said the difference between evaporation and boiling. Um, State and explain what happens to the rate at which the water evaporates as the temperature increases. As the temperature increases, the rate increases. خلاص they're all the same questions يا شباب. So state of matter is يعني quite an easy lesson. صح. طيب, let's move on to PVT, gas laws. Let's move on to PVT or gas laws. PVT, or sometimes known as the gas laws. P, pressure, volume, and temperature. Pressure, volume, and temperature, and how they affect each other. We have three experiments, three very simple experiments. طيب, what are these experiments? طبعا شباب, when we have an experiment, you have to change only one thing. You have to change only one thing. When you change one variable, you need to observe another dependent variable. So you have an independent variable, that's the variable you're changing. You need to observe the dependent variable that depends on this variable, and anything else should be constant. Any other numbers or any other givens should be constant. So in our experiments, we have three experiments. First experiment, now we will say that the pressure is constant. The pressure, the pressure is constant. When the pressure is constant, you can change the volume and temperature together. You can change the volume and temperature together. And this is actually what happens in احنا هنا we said the thermal expansion. This is when I'm talking about thermal expansion. And this is the thermal expansion. Also, thermal expansion. If you have a balloon, if I have a balloon, okay, this is a small balloon with some molecules, some air molecules inside it, and I start to heat up this balloon. I start to heat up the balloon. What happens to the balloon? Well, the volume of this balloon will increase. The volume of the balloon will increase. And I told you, you can do this experiment at home, but you can do it the other way around. You can fill up a balloon with air and put it inside the freezer. If you leave it for a couple of minutes or a couple of hours, the volume of this balloon will decrease. You take it out, you'll find the volume has decreased. But why? In terms of molecules, we have the same number of molecules. خلي بالكم, number of molecules has not increased. In terms of molecules, what happens? Why does the volume increase? In terms of molecules, why does the volume increase? Well, as تعالوا نكتبها. As temperature increases, as temperature increases, kinetic energy of the molecules increases. Kinetic energy of the molecules increases. They gain kinetic energy, so they move faster. Molecules move faster. You can say that they hit the walls, which is no problem, but in this case, the distances between the molecules increases. Okay, it distances hmm, between the molecules, oh, increases. Yes, they do hit the walls ومش عارف ايه بس the distance between the molecules increases. There is a very specific question, very specific question for this experiment. They say, والله, why does the pressure remain constant? يعني دلوقتي you are increasing the temperature. So technically the pressure should increase. صح, technically, which is the second experiment, I'm going to talk about it دلوقتي. But technically, as you increase the temperature, the molecules gain more kinetic energy, they hit the walls with a greater force, and the temperature and the pressure should increase, which is technically correct. But when they hit the walls with a greater force, what happens to the volume? The volume increases. And this is the third experiment. As the volume increases, the pressure decreases. So initially, you increase the pressure slightly because of the temperature, صح? Because of the temperature and the collisions of the molecules with the walls. So the temperature initially, so the pressure initially increases, and then when the volume increases, what happens? The temperature again decreases. Okay, when the volume increases, again the pressure decreases. So the pressure increases, and then the pressure decreases. Therefore, the pressure remains the same. The pressure يا شباب remains the same. هنا the pressure is constant. Oh, it does increase initially, but then it decreases, so basically it will be the same throughout the experiment. خلاص, this is a question. It's not very common. It's not very common, بس يعني because if if you happen to stumble upon this question, you can solve it دلوقتي. Why does the pressure remain constant? It's not just because I said so. No, it's because of, wallahi, initially the pressure does increase because the temperature increases and the molecules hit the walls with a greater force. So the pressure does increase, yes. But so when the volume increases, the pressure decreases because they are inversely proportional. They are inversely proportional. So the initial increase is cancelled out with the final decrease of pressure. خلاص, يبقى this is the first experiment in which the pressure is constant. What about the second experiment? Well, yeah, the second experiment is when the volume is constant. PVT, pressure, volume, and temperature. When the volume is constant. When the volume is, how can the volume be constant? When the volume is constant, I have a fixed steel container, for example, or a fixed concrete container containing some air, containing some air, and I decide to heat up this container. Okay, yeah, I'm heating up this container. What happens? Yeah, as the temperature increases, yeah, I'll say as the temperature increases, what happens? The kinetic energy of molecules increases as well. They hit the walls. Yes, هنا you have to say that they hit the walls. Please, never say that the molecules collide with each other. Never say that the air molecules collide with each other. In Brownian motion, we were saying that the air molecules were colliding with the smoke particles, but never, okay, say that the air molecules collide with each other. Yes, they do collide with each other. I know that they do collide with each other. But for the sake of increasing the pressure or increasing the volume or doing whatever, they need to collide with the walls. They need to collide with the walls. Actually, this is a key word. If you do not write down the walls or the surface or whatever, you will lose a mark. Okay? So as the kinetic energy of the the kinetic energy of the molecules increases, what happens? They collide with the walls. They collide with the walls of the container. How do they collide with the walls? You need to say that they collide with the walls with greater force, okay, with greater force and بصوا كده, with greater force and more frequency, okay, increasing with the greater force, with a greater force and more oftenly or more frequently. Okay, so they increase the kinetic energy, they increase the speed of the molecules. You actually need to say that the speed of the molecules increases. I need to write it down somewhere here. فين هنا? Speed increases. Okay, speed of the molecules also increases. So they collide with the walls with a greater force and more frequently, thus increasing the pressure. طيب يا مستر هنا when the temperature increases you should say that the volume would increase as well. You just said, okay, a couple of minutes ago that whatever matter as it increases the temperature the volume should increase, which is correct, which is correct. بس when I'm talking about a steel container or a concrete container, if you increase the temperature of this container, it would increase, yes, but very, very slightly. يعني if the volume is 200 centimeters cubed, if it increases to be 200.5 centimeters cubed, would that actually affect the volume? لا, it wouldn't actually affect the volume. In the previous example, هنا we had a balloon which was able to be stretched. And I can't stretch this balloon. When you when you expand this balloon, it will expand quite significantly. Initially, for example, it was only 50 centimeters cubed. Finally, it became 200 centimeters cubed. That's times four. So, that is a significant increase in the volume, and that's why we can say that the volume increases. But هنا when I'm saying that the volume is constant, yes, it is constant. بس يعني if it increases by 0.1%, would that actually affect our experiment? لا, it wouldn't affect ours. So we consider it to be constant. We consider the volume in this experiment to be a constant. يبقى هنا when I'm talking about the temperature and pressure, they're both directly proportional. As the temperature increases, the pressure increases, and vice versa. The last experiment is actually the most important one, which is when the temperature is constant. Temperature is constant. When the temperature is constant, how يعني what happens? And I have a piston. You have a piston, okay, with some air trapped inside. You have piston with some air trapped inside, and then you start to push the piston inwards. You're pushing the piston to the left. So I'm pushing the piston to the left. What happens? The air will be compressed. The air inside the piston will be compressed, but the mass will remain the same. The mass of the air inside will definitely remain the same. But we have still 5 molecules of air and the mass remains the same صح؟ the mass will remain the same. طيب what happens هنا? The volume decreases. طيب why does the volume decrease? What happens when the volume decreases? The pressure increases. The pressure increases. In terms of molecules, how does the pressure increase? Well, as you push the piston inwards, as the volume decreases, as the volume decreases. What happens to the surface area inside? What happens to the surface area of the walls inside? Initially, you had a large surface area inside. I'm talking about inside the piston. You had a large surface area. But finally, I had a much smaller surface area. A much smaller surface area. So the surface area, the surface area of the walls decreases. When the surface area of the walls decreases, احنا um, we can remember from the previous lesson when we talked about pressure. Pressure equals force over area. As you decrease the area, what happens to pressure? Pressure increases. صح? Pressure increases because they're inversely proportional. In terms of molecules, what happens? The molecules hit the walls. But never say that they're hitting the walls with a greater force. In this experiment, when I'm talking about pressure and volume, do not say that they hit the walls with a greater force. لا. They're actually hitting the walls with the same force, with the same force, but with a greater frequency. With a greater frequency. يبقى the molecules hit the walls more frequently. You need to say more frequently هنا. More frequently or more often. Okay, هنا the key word is more frequently or more often. Why? Because the temperature doesn't change. The forces don't change. The speed of the molecules doesn't change. خلاص كل حاجة everything's constant. They are hitting the walls, yes, more often. not with a greater force. And therefore, when they hit the walls more often, the pressure increases. They are inversely proportional. But when they're inversely proportional, we can come up with an equation relating the pressure and the volume, which is P1V1 equals P2V2. P1V1 equals P2V2. As the, or you can say that the okay, when this is when the temperature is constant. As the pressure increases, the volume decreases, and vice versa. Sometimes you'd find the equation written as PV is constant, which is yani the same. PV is constant. Pressure or, and volume are inversely proportional. If I want to write, oh, if I want to sketch a graph for this PV relationship, if I want to sketch a graph, the graph would be something like this. Okay, never reaching the x-axis or the y-axis. It's an inversely proportional graph. Okay, هنا for example this is the pressure in pascals and this is the volume in whatever meters cubed or centimeters cubed. Okay, inversely proportional graph. طبعا the volume would never reach zero. The volume would never reach zero. That's why it's an asymptote. يعني the x-axis it would never reach the x-axis. طيب easy صح. P1 V1 equals P2 B2, and this is the only equation in this lesson. Gas laws, we don't have that many laws. We have three simple experiment with only one equation, with only one equation. طبعا this equation could be used. We have several experiments. We have several different types of questions related to this equation, and we will solve together some of these questions دلوقتي إن شاء الله. Okay. طيب, let's solve a couple of questions. Let's solve PVT. I think it's easy, and I think it's one of the easier lessons that we have as well. Okay, yeah, let's open up PVT. Yeah, let's open up PVT. Now we can solve this question if you want to. يعني if you want, let's solve this question together. Page 318. Okay. Okay. Yeah, page 318. Huh. Okay. And you're saying that the pressure increases in temperature of a fixed mass at a constant volume. Oh, constant a volume. Any constant volume, I have a fixed volume. I have a steel or whatever container. So changes from 300 degrees Kelvin to 400 degrees Kelvin. Increases by 100 degrees Celsius. 100 degrees Kelvin, which is also 100 degrees Celsius. يعني. What happens to the pressure? والله the pressure increases. Yes, the pressure increases. طيب, in terms of molecules, why does the pressure increase? يلا, why does the pressure increase? As molecules gain kinetic energy, they collide more against the walls. صح. Okay. بالظبط بالظبط برافو عليك. Yes. Okay. As molecules gain kinetic energy, speed increases. They move faster, hitting the walls, hitting the walls of the container faster and harder. Sometimes you can say and more frequently, and more frequently. Therefore, the pressure increases, or you can say pressure equals force over area. Okay, you can also say that the pressure equals force over area. When the force increases and the area is constant, therefore the pressure will increase. صح. طيب, a sample of gas is at a temperature of is at the pressure of 120 kPa. What's kPa, Mr.? Allah, kPa is kilopascals. Kilopascals meaning that you have to multiply by 1,000. kPa. على فكرة, this would be very common. Okay, kilopascals or megapascals. You can have MPa. Megapascals meaning times 10 to the power of 6 million pascals. صح? Million, which is a mega n. Okay, the volume of the gas is doubled. The volume is doubled. يعني volume is doubled يا مستر. يعني the volume will be multiplied by 2. ايه بقى very simply put, very simply put, what will happen to the pressure? The pressure will be divided by 2. That's it. That's it. خلاص كده يعني that's the answer. Yes, that is the answer. So I can say that the answer is 60 kilopascals. Yes, you can say that the answer is 60 kilopascals. Okay, let's just write down the equation. P1 V1 equals P2 V2. خلاص. P1 V1 equals P2 V2. The pressure, the final pressure is 60 kilopascals. Yes, it is 60 kilopascals. Why? Because هنا you multiplied the volume by 2. Therefore, if I multiply the volume by 2, but the pressure will be divided by 2. خلاص. خلاص. That's it. That's it. Hey, can I solve it numerically? Yes, you can solve it numerically. You can if you want to. يعني ايه you can solve it numerically? You can give whatever volume, whatever initial volume. Okay, you can write whatever initial volume. And for example, the initial pressure was 1120 kilopascals. Initial pressure was 120 kilopascals. If I want to say that the initial volume was 1000 centimeters cubed, خلاص you can write times 1000 centimeters cubed. Can I find pressure 2? P2. طب what is V2? The volume is doubled, therefore هنا it has to be times 2000. You can just divide by 2000 and the volume and the pressure will be 60. You can solve it numerically. You can solve it numerically if you want to. طيب حلو. Let's move on. PVT. Last question. PVT was page. Da, da, da. Page cam. And we had a lot of questions in PVT, huh? PVT. Hmm. Uh, okay. PVT. I know. I'm sorry. The pages aren't numbered. بس oh, here it is. It's actually page 359. 359. طيب يلا. The temperature of the bottle and its contents are increased. I'm increasing the temperature. Explain in terms of particles how the air pressure inside the bottle changes as the temperature increases. Again, I'm increasing the what? I'm increasing the temperature. I'm increasing the temperature. يبقى what happens with pressure? Pressure increases. صح برافو عليكم. Okay. Pressure. هم؟ ايه بتقولوا ايه؟ As the particles gain more kinetic energy colliding more against the walls. ماشي. Yes. Okay خلاص احنا we need to say the pressure increases. يلا. ال pressure increases, kinetic energy increases, the speed of the molecules increases. Again يا شباب I'm writing quite quickly بس انتوا you need to write with more details. Kinetic energy of the molecules increases, the speed of the molecules increases, molecules hit the walls اهو molecules hit the walls ايه بقى faster and harder faster faster and harder and more frequently and more frequently increasing the pressure. Okay, our pressure equals force over area and the volume is constant. ماشي. The lid is removed. When I remove the lid, state and explain how the air pressure inside the bottle changes when I remove the lid. How will the pressure? I know you. A lot of you do this in school. How does the pressure change inside the um, bottle? والله the pressure will decrease. صح؟ It's quite obvious the pressure will decrease. Why will the pressure decrease? Okay. يعني if I want to explain it decreases and you're saying that it decreases to atmospheric pressure. Yes, it does decrease it to the atmosphere. It becomes equal to the atmospheric pressure. That is correct. It becomes yes, that is 100% correct. You can say so. Yeah, but what happens to the pressure? It decreases. Okay, decrease in pressure. It becomes equal to the atmospheric pressure. سهل صح؟ يلا بينا. In terms of momentum, how the gas exerts a pressure. I guess we said this last time. How does the gas exert a pressure? والله air molecules يلا. Yes, move. Air molecules move fast and random. You have to say that they collide. Oh, colliding with the walls, with the surface, walls or whatever. Uh, exerting a force أو changing the momentum الأول. changing the momentum, thus exerting a force. يلا. changing their momenta. Okay, momentum. Thus exerting a force over an area. Over an area. يلا. Which is pressure. Which is pressure. Force over area. سهلة. ماشي. Pressure. صح. Okay. Temperature of a sample of gas increases at constant volume. Again, constant volume. احنا we just said it. How does the pressure increase? Or how does the pressure change? It increases. So pressure increases. Why does it increase? Because they gain kinetic energy. The speed increases. They hit the walls faster and harder, thus causing a greater force and increasing the pressure. صح. طيب. Another sample of gas is in a sealed volume containing volume is 170 centimeters cubed and exerts a pressure of 9 times 10 to the power of 4. The volume decreases by 70. Decreases by 70 at constant temperature. حلو. Okay, find the pressure P1 V1 equals P2 V2. P1 pressure 1 is 9. لا 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 لا, not cross multiplication. Into you're saying cross multiplication. 100% wrong. Never write it down as cross multiplication. Why? Because they are not directly proportional. They are inversely proportional. Inversely proportional. خلي بالك. Okay, so 9 times 10 to the power of 4 times V1, which is 170, equals P2 times, what is V2? What is V2 يا شباب? Is it 70? Is the second volume, is the final volume 70? لا, it's 100. Yes. Okay. It decreases by 100 by 70. So basically the final volume would be 100 centimeters cubed. It decreases by. So V2 is 100 divide by 100 when you divide by 100 هيبقى كام? The pressure will be around 1.5 times 10 to the power of 9 صح? To the power of 5. Yes. Okay. Pascals. Hmm. Any questions? يلا. Okay. Changing. Okay. احنا we haven't explained this yet. احنا we will explain it إن شاء الله next time. Cylinder is placed inside a freezer. The air in the freezer is an atmospheric pressure. The area, okay, in contact is 2.4 times 10 to the power of negative 3. Can I find the force? Can you find the force? Yes, you can find the force. Pressure equals force over area. So pressure equals force over area. So basically the force is equal to the pressure times the area. صح? And pressure, atmospheric pressure times the area. Very simple. 1.5 times 10 to the power of 1.0, I'm sorry, times 10 to the power of 5 times 2.4 times 10 to the negative 3. This would be negative 3, 5 to 40. 240 newtons. سهلة دي. This is easy. While the cylinder is in the freezer, it moves a distance of 0.021 meters. What is the work done? Wallah, work done equals force times the distance moved. Force times distance moved. You have the force 240 times the distance, which is 0.021. So the work done would be something around 5 joules. صح? 5 joules. Very small distance moved, very small force applied, but therefore the work done will also be very small. The change in internal energy, I know I haven't explained it yet. This is the E equals mc delta T. We will explain it inshallah next session. Okay, E equals mc delta T. But when the temperature reaches negative 18 degrees Celsius, the pressure of the gas in the cylinder is still equal to that of the atmosphere. The pressure, بصوا, the pressure is still equal to that of the atmosphere. In terms of the particles, how does the pressure remain equal to its original value? How does the pressure remain equal to the original value? والله, the temperature is increasing. Temperature is increasing. طيب, temperature is increasing or decreasing? It's decreasing, صح? Oh, it's decreasing. Temperature is decreasing. طيب, when the temperature decreases, what happens to the molecules? They move slower. They move slower. ماشي. فinitially they are hitting the walls less frequently and with the less force, and therefore initially the pressure decreases. Initially the pressure decreases. But then as the volume decreases, what happens? The pressure again rises. The pressure again rises, so it becomes the pressure goes back to its initial number or initial value, initial magnitude. Okay, so they actually cancel out each other. But we can write it down. As the temperature decreases, as temperature decreases, molecules move slower. Molecules move slower. Moving slower. Hitting the walls. Oh, hitting the. Can I say PV is constant? You can say it for the second part. Yeah, you can say that. Hitting the walls with less force. Decreasing the pressure. صح? Decreasing the pressure. And volume. بصوا, and volume. When the volume decreases, when the volume decreases, and you need to say that the volume will decrease. So as the volume decreases, what happens? The pressure will increase. Why? Because the molecules hit the walls more often, more frequently. As the volume decreases, the molecules hit the walls more frequently. Again, صح? There is an inward force on the piston causing it to move inwards. Hina, I'm not asking you about the forces. I'm not talking in terms of forces. لا. لا لا, انت هنا you don't need to talk about the forces. هنا you do not need to talk about the forces. Probably in the next question he might ask about the forces, but يعني for this question he doesn't want you to relate to any forces. Okay, the molecules hit the walls more frequently, thus increasing the pressure again. Thus increasing, okay, the pressure. The two effects cancel out. The two effects cancel out. Or you can say the initial decrease in pressure is equal to the final increase in pressure. So they are equal. خلاص. They cancel out. So the pressure remains unaffected. Or the pressure remains constant. طيب, as the temperature of the metal cylinder decreases, the volume of the metal decreases. The decrease in the volume of the metal is much less than the decrease in the volume of gas. Okay, quite obvious. يعني. Explain in terms of the particles of metal. In terms of particles of the metal. Why the decrease in the volume of the metal is less than that of the gas? In terms of هنا forces. Oh, هنا I'm not going to talk about the forces. Yeah, in terms of forces of the metal, of the solid, in terms of the solid. أنا خلاص, states of matter in solids you have much greater forces between the molecules, and because the molecules are at much closer distances, صح, they are touching ولا they are closely packed ولا whatever, صح, you can say that the forces between the molecules الforces between the molecules are very strong in solids, okay, and the distances are very close. Distances between the molecules are very small مثلا ولا أي حاجة أو very close أو whatever. Okay, يبقى the molecules are very close together and the forces between the molecules are very strong. That's why you cannot easily compress or expand a solid. Okay, that's why, for example, a very common question is why are gases compressible but solids and liquids are not? Well, solids and liquids don't have that much space between the molecules, or you can say in terms of gases have very weak forces and very large distances between the molecules. That's why gases are compressible but solids and liquids are not. Okay, yeah. Hmm. Any questions? Momentum احنا خلاص we said this question what happens with pressure of a constant volume, again constant volume when the temperature increases خلاص احنا this is the most common question, okay, most common question when the temperature increases the pressure increases and we know why molecules move faster والكلام ده كله يلا gas bubble is released from the bottom of the lake, the gas the volume increases, explain why the volume of the bubble increases. Again, when the volume when it's rising upwards, if you have a bubble at the bottom of the lake, in terms of liquids, in terms of liquids, if I have if something is at the bottom of the lake, this means that the depth has increased. Depth below the surface of the lake has increased. Whenever you increase the depth below the surface of the lake or below the surface of this liquid, the pressure increases. Therefore, when it's rising upwards, what happens to the pressure? Well, pressure decreases. So, pressure decreases. So as it's rising upwards, pressure decreases as it's rising. Therefore, the pressure and volume are inversely proportional. That's it. Okay. Pressure decreases. Why? Because pressure and volume are inversely proportional, or you can say P1 V1 equals P2 V2, or you can say PV is constant. Okay, yeah. Next question is an easy question. I don't know why 4 marks. Okay, بس يعني I know why now. Because you tend to forget something very important in this question. The volume of the gas bubble ماشي طبعا the unit is worth 1 mark بس يعني it's not the main point I'm talking about in this question. And you're saying if you forget to write down the unit, you lose a mark. Yes, but there is another crucial part of this question, not conversions. Into conversions are the same, and the volume into you will write the volume in centimeters cubed. يعني initially the depth was 3 meters, but then the volume when it's 0.5 meters, you can find the volume at 0.4. Yes, you can. يعني I can find the volume and I can write down the volume in centimeters cubed. That's not the issue. That is not the issue. The issue is can you find the pressure? Can you find the pressure or the total pressure to be بقى يعني very specific? Can you find the total pressure on the gas molecule at the bottom of the um, lake? And can you find the at that depth يعني at that depth, and then can you find the pressure of the pressure on that bubble at the other depth? Yes, you can. Like pressure equals rho gh. Pressure equals a rho gh. But for this case, for this question, since he gave you the atmospheric pressure, he gave you what, Shab? The atmospheric pressure. Then you need to add this atmospheric pressure while calculating the pressure. إيه ده يا مستر? And this is a very difficult question. That's why it's worth 4 marks. That's why it is worth 4 marks. Can I find P1? can I find the initial pressure? اه rho GH density times G times the height. what is rho يا مستر؟ initial density of the water is 1000 صح؟ density of the water is 1000 يلا 1000 and G 9.8 and the initial height okay was 3 meters صح؟ يبقى what is the final answer? Let me find my calculator. 30 times 8 is 29,400 صح؟ 29,400. بس this is the pressure بصوا بقى this is the pressure due to the water alone due to the due to the water alone. You need to find the total pressure. How can I find the total pressure? You just need to add بصوا كده you need to add the atmospheric pressure, which is 1 times 10 to the power of 5. You need to add the atmospheric pressure. Okay, so 29,400 plus 100,000, this would give you a final volume, final pressure of 129,400 pascals. This is P1. Can I find P2? Yes, you can find P2. Again, rho GH. 1000 times 9.8, but the height of the depth is 0.5 meters. 0.5. Yeah, this is كام؟ 4090. 4900. Add يلا add الايه 1 times 10 to the power of 5, which is 104,900 pascals. This is P2. طب can I use بقى the equation P1 V1 equals P2 V2? Yes, you can. يلا P1 V1 equals P2 V2. What is V2? It's basically P1 V1 over P2. 129,400 times 0.40 over 104,900. يلا the final answer would be كام 129 over 104 which is 0.49 0.49 or 0.493. Okay, 0.49 or 0.493. You can round it up to 0.5. Again, do not forget the unit, which is centimeters cubed. Centimeters cubed. This is a difficult question, to be honest. This is a difficult question. It's not that common. It is not that common to use the pressure of the liquid, okay? And it's even less common to add the total pressure or to add the atmospheric pressure. It is a very difficult question. So but it's okay. It's okay. Okay, 4 marks. Quite worth the 4 marks. عشان كده variant 3. Variant 3. It has to be hard. It has to be difficult. Okay? Variant 3 questions are always a bit more difficult than variant 1 and 2 questions. Okay? طيب